Welcome to NASA iTech. Thank you for being here. We have an exciting night this evening where we're going to listen to 10 entrepreneurs giving their pitch on the technologies that they're developing that have both an Earth and space application. I'm Kira Blackwell.
And I'm MARCHEL HOLLE. I'm manager of DC operations for the Space Foundation, and I'm representing the New Gen team. So we have a great group of folks here at the Space Foundation who have put on an amazing show. So I got to give props to Bernadette, I got to give props to Becky and Jody and Kelly, and you guys have just been killing it. And so I wish all of you could be on stage, but I will have to suffice.
Did you forget Tom? Because I think he pays the bill for all of that.
Tom is a New Gen emeritus, so you're an honorary member of this. So thank you, Tom.
And so I'm amazed because this is his first ever Space Symposium.
It's
Woohoo,
it's kind of like hazing. Yeah.
Welcome to the club.
Thank you very much. Yeah.
And we partner, well, the NASA team, the NASA iTech team, we partner with the Next Gen or New Gen?
New Gen, yeah.
New Gen, because they won't let us into their parties otherwise. I mean, I have to be like under 35, and they never believe me when I get to the door.
Yes, it's a very exclusive club.
Apparently,
yeah.
Apparently. Well, so you guys, I want to kind of go through what you're gonna see tonight. So the first thing that we're gonna do is we're gonna introduce ourselves, and I'm a little bit curious. Did you get a new hairdo?
Well, yeah. So unfortunately, I shorn all this off. And I'm wearing a suit now. So,
I don't know why it's just my picture up there, but I probably dropped the ball on that.
No, I'm sure it was mine. So.
This is how it works. The entrepreneurs have 3 minutes to give their pitch. How many minutes? Yes,
3 minutes?
Just 3. What happens if they go over?
I think there's that, what's that movie?
Jaws.
I've never seen it.
I know, probably way too young.
What is it about?
But there's a theme song to Jaws. Does anybody know what that sounds like?
Da-da, da-da.
You've never seen the movie, clearly.
I've seen Jaws once, and that's basically it.
It's like, dun-dun, 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 right?
Right. So in actuality, like you were trying to explain it to me.
Susie, pick up your mic. Miss Know-It-All,
Wait,
give it to her.
Wait, come on.
Come on. Look, you can't put out and not actually do it. Okay, there you go. You win.
The shark fin? Yeah.
Definitely it. So if they go over their 3 minutes, the thing is, they hear that sound effect. Can you try that again? And it always, it always happens once. There we go.
I liked yours better, though.
Hey. So one of the 10 will do this. I'll be amazed if you don't, but one of them will go over their 10 minutes, and we'll get to hear that clever music, or their 3 minutes. We'll get to hear the clever music. Yeah, I just cut your time. Sorry. And so we keep it really tight. At the end of all 10 companies presenting, we allow the judges to we give them 15 minutes. They actually have a time limit too. And collectively, they're allowed to ask questions, additional questions that they would like answers to when the entrepreneurs were presenting. After they collect the answers to those questions, after their 15 minutes are up, we will actually walk off stage. We'll have a guest speaker that will be speaking here on stage, and we will go and make a decision on who the top winner is. So does the Space Foundation provide something to the winner here?
Just only the most amazing gift ever.
What is that?
And that would be a complimentary registration to the 36th Space Symposium.
Woo!
So everyone, mark your calendars. It's going to be big. So
that really is, I mean, that's a pretty good deal.
it is a pretty good deal, yeah.
So from NASA, well, we don't give money. Sorry. There's laws, and I don't look good in orange or stripes, so I just need to steer clear of that. But what we do, what the top winner tonight does get is they actually will automatically be selected as a semifinalist. What does that mean? If we get 150 proposals in for one cycle that we're doing, NASA only actually sees about the top 25, the top scoring 25. So it will guarantee that our Center Chief Technologists will be able to evaluate the technology, and you have a shot at making it into the top 10. And it doesn't mean that just because you didn't just because you didn't win tonight, because I won't let them pick more than one winner. I know, they don't like me for that, but I don't. But it doesn't mean because you didn't win tonight that you won't actually be in the top 10. That's not what that means. It means they can only pick one out of all the great technologies they're gonna see tonight. So just keep that in mind. This is cool. We will need technologies to get boots on the moon. That's right. I cannot tell you how excited I am, actually, to be working in the space industry, to be working for NASA, knowing that in 5 years, we've been told we are going to the moon, and I believe it. I actually believe it, that if we pull together, we can do this. And so when I see that video, and it talks about the technologies we'll need to get there, that's going to require more than just us, and that's the reality. But we're good with that. So, next slide. So NASA iTech searches for technologies that are actually solving problems on Earth and for us in space, and that are not already funded by the federal government. And that's important because we want to find the things that are actually the technologies we haven't seen yet. What we need for NASA, what the commercial market needs, we go out and find innovators. Applying, we've made it pretty simple. It's only a 25-page white paper. No, just kidding. It's a 5-page white paper to make it simple. And we eliminate any IP concerns because, well, we don't give you any money. Sorry. We convene the right people, and then we get out of your way. Really, we really move out of your way so that entrepreneurs and innovators can do what they do best, and that's innovate. And
Kira, we were kind of talking about this before. One of the things I find so interesting about NASA iTech is just how hands-off it is. I mean, there's this American entrepreneurial spirit, and all of a sudden you're going to have people, innovating at the speed of now, right?
Right.
And so it's really cool that you guys are doing this.
Thank you. Yeah, I feel very fortunate that I'm able to work for an agency that allows us to do that, and that's the truth. I'm always surprised when my badge still works when I walk in. I'm like, they don't know it's me. But anyway, I press forward. So I'm a numbers girl. I can tell you how great it is, but these are the numbers. So in about 24 months, we've received over 500 proposals. 50 finalists have been selected, and those 50 finalists have raised well over $410 million of private investment dollars. That's right.
That is.
And I will tell you that it is a team effort. I'm up here on stage, but it's these people, the judges, our center chief technologist. It's the team that's behind this wall that you'll never see, or you maybe at some point. It's the guys that have the cameras. It's the agency that I represent that continues to fund it every single year. And the entrepreneurs that actually participate, investors that show up, our contractors that see the technology, see the value, and want to partner. So those numbers are pretty incredible, but that's what makes all of this happen. And I think I'm running out of time. So you think we should get started?
I think we should get started.
So I'm going to hand it off. So our first entrepreneur will come up. Jen's going to help him, and I'll get out of their way, which is what I do good. Oh, wait. Can we introduce the judges? Because I didn't do that. I'm going to start with Chris. Yeah, he's looking at me like, what? So we're going to start with our first judge at this end. They're going to just tell you their name and where they're from. That's that's important because I said I couldn't do it without them, but I didn't let them say who they were.
Hi, I'm Chris Culbert from Johnson Space Center.
Hi, Shay Faring from Firefly Aerospace.
Ramona Travis, Dennis Space Center.
Harry Partridge, Ames Research Center.
Rich Godwin, Space Technology Holdings and Starbridge VC.
Susie Cunningham, Kennedy Space Center.
Peter Hughes, Goddard Space Flight Center.
Dr. Richard Benassi, Tampa Bay Wave.
Dennis Andrusik, NASA Headquarters, the Deputy for Science.
That I started the program under, by the way.
Randy Likens, Jacobs Space Exploration Group. Michael Limbeck, University of Illinois Aerospace Engineering.
Dr. Limbeck.
Michelle Freeman, Mayo Clinic.
Justin Williams, Tin Man Kinetics.
So can we give them a round of applause because they're volunteering their time to be here to help with this process. And this process is what helps these entrepreneurs raise that kind of money. So one more time, a round of applause for our judges. Thank you for... Okay, our first entrepreneur. We'll move.
So let's get down to brass tacks. You have information in your data that is screaming to tell you something, but your systems can't hear it. Your sensors are performing better than you think, but your systems can't see it. In fact, the information you're missing in the data could actually the timely situational information that could help you with threat reduction. Could actually be the differentiator that topples your competitor. It could very well be a critical finding inside the brainstem of a 12-year-old girl that had her doctors baffled and her parents desperately praying for answers. If you notice in the top right, Baker Sy was approached by a physician group to look at a deck of MRI slides. Upon our analysis, while we were not able to find the actual cancer because it's actually smaller than a voxel, the radiologist believed that Baker Sy was showing them the effect that the invisible cancer was having on the surrounding cell tissue, thereby leading them to investigate further. It's simple. There's more information in your data, and you need it, and only Baker Sy can help. Hello, everyone. My name is Tim Natty. I'm the founder and CEO of Baker Street Scientific. Together with my co-founder and CTO, Rob Brinson, our team has developed novel science and technology that provides better, faster, and more accurate analysis for current underperforming conventional systems. Don't be fooled. While we may hail from little old Rome, Georgia, we're disrupting data science in ways Silicon Valley is not. Baker Sy can help physicians understand better, help energy pioneers explore smarter, help Intel communities act faster, help dreamers and researchers dig deeper. But wait, I know what you're thinking, but what about the accountants? We've already invested massive resources deploying assets around the globe in space and inside our bodies that are driving our products and services. How in the world can we fix this? Well, with Baker Sy, you can overhaul your system on the software side by augmenting the already collected data. Without laying a finger on them, you can literally increase the return on investment in multiples that both shareholders and clients keep them happy. Baker Sy's abilities bring new life and oftentimes functionality to your current systems. Newfound data can be newfound revenue streams, newfound efficiencies, or competitive advantages. You will discover more without destroying your CapEx budget. In conclusion, with Baker Sy, let's go forth. Let's save more lives. Let's catch more bad guys. Let's appreciate interesting things in space photography that theoretically would never be seen with the naked eye. Let's blaze new trails, and most importantly, please don't stress out your accountants. It's this simple. If you had the ability to know more about how to change your world, how would you do it? Let Baker Sy help. We'll see you in the back. Thank you.
Hello, everyone. Power generation. Power generation is a goal of humankind for the history of civilization, including harnessing heat from fire and generating electricity from solar, wind power, fossil fuels, and nuclear power, among others. I'm Benji Balzer, CEO of ION Power Group. At ION Power Group, we have developed and patented a technology which harnesses electricity from atmospheric ions. This is Clint McCowan. He's our lead researcher, and he's going to tell you how ion harvesting technology works.
Ion harvesting leverages the unique qualities of our patented carbon nanofiber to extract useful electricity from ions that are native to a planet's atmosphere. It's really quite simple. We lift up our carbon nanofiber, our patented ion collectors as we call them, up into the atmosphere using towers or in some cases tethered balloons. The higher the better. The higher, the more power. And it encounters the ionic energy, the ions which are native to planets' atmospheres. In fact, you see a list of planets' images right here, all of them possessing some form of atmosphere. And the energy is transferred to that carbon nanofiber, and it goes down the tether to the ground where it's collected and used. We've achieved technology readiness level 3 and higher as defined by NASA. As you can see right here, there's some examples. We have powered motors, lights, electronics, water electrolysis to produce hydrogen and oxygen gas, and even 120 volt AC current to power, in this case, a light bulb. The battery here was charged using this technology, ions from the air, right here in front of your eyes. Dr. Baumgartner, the senior scientist on the far side of the screen, with the German Aerospace Center, published a report in which he recommends that future Mars missions use this technology as a reliable source of energy on Mars. And on this side of the screen, Dr. Philip Metzger, who in 2011 was voted the NASA Kennedy Space Center Scientist Engineer of the Year, he predicts in his report that this technology can produce electricity cheaper than solar, possibly up to 65 times cheaper than solar here on Earth. In fact, he goes further.
I want to know how exactly does the fibers collect the ions?
Okay, good question, Benji. At a microscopic level, the fibers are very
Investment bankers make billions using fast data processing trading algorithms with the most advanced software code available. What if we could use this same tech for embedded systems for space, robotics, drones, and self-driving vehicles? Clepsydra Robotics has done this. My name is Chuck Lauer. I'm the North American rep for Clepsydra Robotics in Zurich, Switzerland. And I'd like to show you a use case that demonstrates what Clepsydra can do. What you see in this chart is a application from our first customer. They are an autonomous drone doing wind turbine inspection. And if you see the picture in the upper left, that is prior to our system being put into their analysis. They had two requirements. One, They have to get 20 frames per second of HD data, inspecting both sides of each blade. 2, they've got to use a vision-based navigation system to fly up and down each blade as quickly as possible, because these are $5 million wind turbines. They're there to make money, and they've got to be serviced. What you see in the vision processing improvements that we can get is the difference between the upper picture and the lower right picture. The upper left picture shows, okay, that's a part of a turbine blade. What you see in the lower right picture is the improvements from the Clepsydra embedded software package. We are taking a picture and turning it into actionable information with a program that can use actually less CPU power and less space power for doing the same job. In a processing side, for things like the autonomous navigation system, you need very high data rates in order to be able to use autonomous systems properly, especially when you're dealing with $5 million pieces of equipment, or millions or billions in the space environment. The graph on the lower right shows that the Clepsydra system, when you're dealing with 2,000 to 3,000 hertz data rates, is stable all the way up to the top. That's ROS code, either single and multi-thread, dropping code as you get to the higher data rates. The Clepsydra system is stable all the way up through 3,000 hertz. And what we are doing is now selling this system. We are done developing. We have a product, we have customers, we have terrestrial applications, we have space applications. This would work for Earth observation, for lunar robotics, lunar landers, and we have demos available. We're happy to talk to any users that are out here, and we would love to be able to put a demo in your kit. If you have a high data rate analytics and onboard processing system, we're here to help you. We can demo for you, and we want to show you what we can do. Thank you.
Hello, everyone. We recognize that astronauts have health and wellness concerns, and that's vital to the mission. In a test study that we did recently, we detected abnormal heart rhythm in a patient. The patient name was Mary. We found out that she had a history of heart attack, and a couple of days later, she died of heart failure. Without smart garment technology, we could have prevented that, and maybe Mary would still be here today. My name is Alex Thornton. I'm CEO and founder of Physio. I work with a team of machine learning, artificial intelligence, and sensory experts based out of Aurora, Colorado. We have created a smart garment that monitors real-time health, along with identifying risks, predicting occurrences, and comfortable to wear. In collaboration with the University of Denver, we were able to make this a success. The results were pleased, and we were approached by the Air Force regarding our technology. Other available solutions require adhesive electrodes, more wiring, bulky controllers, and they don't have a physical connection. We're eliminating those elements with our technology, as well as providing astronauts with access to their vitals, such as heart rhythm, glucose levels, hydration levels, and skin temperature. Additionally, ground control can have immediate access to this information by recognizing crew-wide events, alarming crew-wide events that other members may not be able to recognize aboard an aircraft. Going forward, when efforts reach Mars and beyond, we anticipate our health monitoring being really vital to the mission and really urgent. Together, we can revolutionize scientific endeavors in space and on Earth to reduce costs of long-term health. That concludes my presentation, and thank you, guys.
Hi, I'm Dean Hedman, and this is Mitch Miller. We're taking on the task to see a fully renewable electrical grid in our lifetime. As we transition to clean electricity, we need electrical storage. We are Atlas Power Generation, based out of Vancouver, Canada, with established collaborations with local universities, SFU and UBC. We have a number of granted and patent-pending technologies, our primary focus being deflection conversion. We are commercializing this technology through a grid-scale storage solution for load shifting.
So deflection conversion and our grid scale energy storage have some pretty amazing features. So our grid scale solution offers round trip efficiencies above 95%, and that's game changing. So traditional energy storage based on capacitors in the market is 84 to 88%, similar with lithium ion, and for pumped hydro, that's 80%. We also can fully charge our entire storage bank and discharge it in 5 minutes versus over multiple hours with existing technologies on the market. And we get between 1 and 2 million full charge discharge cycles versus 6,000 to 8,000 with lithium ion. Additionally, we have the core technology is our deflection converter technology. This is a integratable electronic system. It's a core power technology for charging capacitors. So it allows you to integrate it into your systems and have higher efficiency. So what does higher efficiency mean? Lower heat, lower cost, lower size. This is another major tool for the toolbox of electrical engineers and circuit designers, and it offers the ability to do some pretty amazing things.
Mitch, how would this affect a server farm?
So most people don't realize that capacitors are in virtually every single electronic device that you own. So a server farm is no different. There's capacitors integrated through many of those circuits. So if you can increase the efficiency of those circuits, you can save money. And that means server farm operators will save money and save energy.
We are currently looking for investors, partners, tech companies to license our deflection conversion technology. Thank you very much.
We're all about to show our age. Raise your hand if you remember wallpaper from the 1980s. All right. It's also in the bathroom here, in the girls' bathroom. I haven't been to the men's. Now imagine this wallpaper is a power system. The power system starts with the flowers. This is your antenna. The stripes going down, this is in the bathroom. The stripes going down are the harness. And then the cutout around the electrical outlet supply. Now imagine that this wallpaper can also protect you from radiation. This wallpaper can go in cube satellites or something as large as the Orion vehicle. I'm Amanda Smith from New Promethean. I am the co-founder and VP of Aerospace Engineering. We're located currently in Southern California, but moving to Boulder very soon, thankfully, because I live here. Our business, graphene etching. We have a globally patented process to etch nanostructures using DNA origami. Let's start with the graphene. This is a 2D structure material discovered in the early 2000s that's lightweight, temperature resistant, strong, flexible, transparent, and resists radiation. DNA origami. Let's not complicate this. DNA structures are folded just like origami pieces of paper. That DNA origami is then etched into the graphene, and voila, wallpaper. This tech has the ability to disrupt not only the power supply industry, but also the radiation. I worked on the Orion program for 8 years. On the Orion, we have solar panels. These solar panels need the sun. If Orion had our technology, all they would need is radiation from the environment, collected through rect antennas, down through the harness, and into the power supply. Now, the harnessing on Orion, quite complex, weighs a lot, takes up extra room that we could use for other subsystems, and needs extra structure in order to hold on to it. If we used just this simple wallpaper, all of those problems go away. Schedule is reduced, cost is reduced, weight is reduced. Then there's the batteries. On Orion, the batteries are about the size of your carry-on luggage. There's 2 of them. Can you imagine if your cell phone was the batteries on Orion? New Promethean is looking for investors as well as vehicles that need this kind of wallpaper. Thank you.
I would like you to imagine that you are halfway into a 21-month mission to Mars when you wake up with excruciating pain in your side. You know enough that this feels like a ruptured appendix and you need an emergency appendectomy right away. Unfortunately for you, you are the flight crew's medical surgeon, and the pain is so intense that there's no way that you could be awake during a procedure, let alone perform it. Thankfully, the mission planners at NASA thought about this scenario and have been preparing for it. Howdy, my name is Matt Sanders with Stress Engineering Services. Stress Engineering is a technology company that is passionate about tackling the most technically challenging problems, and we have been for over 45 years. Our team, led by Dr. Grant Schaffner, is developing a technology that provides the ability for a surgical robotic control system to learn from surgeons, preserve that knowledge, and then use it reliably and safely. The robot control system uses recurrent neural networks to autonomously perform the surgical motions of instruments during a procedure. The feasibility of this technology has already been demonstrated by performing a mastoidectomy on a cadaver specimen. The movements of surgeons are recorded in advance during surgical simulations and used to program the system's neural networks. The data is then converted over to an executable form that can be used on any surgical robot platform. As you can imagine, the applications for this can go beyond spaceflight. Imagine a warfighter injured in a remote battlefield, or a child in a small village born with a birth defect. There is only one pediatric surgeon to 5 million children in sub-Saharan Africa. As our world population increases, access to skilled medical care will become more scarce. This software bridges the gap between where established medical procedures exist, but they cannot be performed for logistical reasons. The commercial market viability on Earth alone is tremendous. As advances in healthcare continue to push the human lifespan higher and higher, there is a tremendous need for reliable, efficient healthcare procedures in distributed locations. There's one surgical robot company alone who in 2018 had a revenue of $3.7 billion. This technology isn't just limited to performing procedures. Once the surgical data is captured, it can be used to train new surgeons and compare them with the world's best. By leveraging advanced computing and machine learning, we can help address NASA's critical need to perform medical applications in space. Thank you.
Good evening. It's an honor to be here tonight. Today, rocket propulsion systems are saddled by lengthy delivery timelines of products. They also are costly. Steelhead Composites offers our combined pressurant propellant vessel, or CPPV, solution to be able to satisfy the needs of the space community. We believe that it applies to the entire space community across the military, the government, and also commercial space. And we believe that that can bring missions like supplying supplies to the International Space Station, as well as the ability to deliver satellites into orbit and military applications, amongst other possibilities. I am Stephen C. Arsberger of Steelhead Composites from Golden, Colorado. We were established in 2012 with the explicit intent to provide enabling product capabilities to the automotive industry. Tonight, we seek to be able to introduce our CPPV to satisfy the needs of the space community. Our CPPV is based on a simple design, safe, and affordability. The ability to deliver simplicity in design is afforded from a vessel within a vessel type of configuration. The outer composite overwrap pressure vessel satisfies the structural components and can be directly integrated into the spacecraft. The ability to have a structural capacity that then embellishes and encompasses an internal sleeve that holds the pressurant and then consistently and reliably delivers the propellant adds safety. It also adds the ability to be able to provide and contain toxic components like hydrazine. The ability to do that in a safe and consistent manner affords the ability to have affordability. Affordability comes from not only reuse applications of our system, but also the ability to impart the simple design considerations in combination with a strong and consistent supply chain. Overall, taken together, we believe this affords a third of the delivery time with 50% or up to 50% in cost reductions from compact, reliable, consistent performance in mass platforms. As an organization, our goal tonight is to be able to interact with this community, seek investments to mature the technology, and bring this technology from a prototype into a manufactured product satisfying space needs. Thank you.
Getting into space is expensive. It's really expensive. The size and the mass of a satellite are real cost drivers. And when you consider things like solar arrays and deployable antennas, the problem is further compounded. Oxford Space Systems solves some of those problems. Hi, I'm Mike Lawton. I'm the CEO and founder of OSS, and we combine our own proprietary materials together with origami techniques to give a new generation of deployable antennas and structures that are lighter, less complex, and more storage efficient than those products in current commercial demand. And I've actually brought some of the materials this evening to show you. So, you're all familiar with carbon fiber. If we play around with the chemistry of carbon fiber, we can make it do really interesting things. So there is a deployable carbon fiber. So we get all the advantages of carbon fiber, but now we can stow it in a really small space. Combining that with our proprietary modeling tools allows us to innovate products faster than it's been done before. And we believe we've set a world record going from company formation, developing this novel material, and demonstrating it on orbit. We achieved all that in less than 30 months. And if you look at the photograph in the top left-hand corner, you can see one of our lead customers, Airbus, deploying a target with our material, which they then shot at with a space harpoon, and the mission went perfectly. Now, if we can play the video, a more exciting use of the technology is to give us a new generation of deployable antennas. And this is a class-leading high storage efficiency antenna that can deploy up to 5 meters in diameter. Now, that prototype triggered the highest award from the UK MOD for a first-time supplier, and they've set us the challenge of demonstrating that technology on orbit in less than 2 years, and we're going to do it. Now, if my loyal assistant will come to the stage, I'm going to demonstrate another material to you, but I don't have enough hands, so I'm going to pass the microphone over. I'll deploy it first, then explain what you're looking at. Thank you. So what I tried to show you with just 2 hands is a pre-shaped membrane material, which gives us a new generation of deployable parabolic antennas. For the RF guys in the audience, we've tested this up to 35 gigahertz. We're getting 45 dBi gain, which means it's comparable to fixed dish antenna technology, but of course is a fraction of the weight. So we don't just see this being useful for a space segment, but also terrestrial use. And we've already been approached by a number of defense contractors with a view of displacing terrestrial fixed antennas. I've got a lot more technology to talk to you about, but I'm running out of time, so hopefully I've sparked your interest, and I look forward to answering your questions. Thank you.
How many fully reusable launch vehicles exist today or have ever existed in the past? 0. We are Exodus Space, and we're developing a family of fully reusable launch vehicles. 2-stage to orbit, horizontal takeoff, horizontal landing. My name is Miguel Ayala. I'm the CEO of Exodus Space, based in Denver, Colorado. Our family of fully reusable space launch vehicles, space planes, consists of 4: micro, mini, cargo, crew. Simple. Micro, operational by 2025, 500 pounds to LEO, unmanned. Mini, operational by 2027, 2,500 pounds to LEO, unmanned. Cargo, operational by 2031, 10,000 pounds to LEO, unmanned. And finally, crew, operational by 2034, 20 passengers to LEO, human-rated. Our vehicles look like fighter jets. Takeoff powered by jet engines. They take off as a single stage, as a single system. Once they reach a certain altitude, the booster stage separates and comes back and lands on a runway. The nose section, the orbiter, continues to space, conducts operations, and comes back and lands on a runway. The services that we are offering with our small vehicles, micro and mini, will include satellite deployment, in-space satellite servicing, space debris collection, and other emerging needs. Our larger vehicles, crew and cargo, they will support crew and cargo transport, and also intercontinental travel and space tourism. There are over 100 launch vehicle companies right now. But the thing is, over 95% of them are focusing on vertical takeoff, expendable rockets. What we're offering you is a long-term sustainable solution to completely transform the way we access space. It's about that time. We're looking for something new. And our team, with this technology, what we offer you is full reusability, launch from anywhere around the world, from any spaceports around the world. With horizontal takeoff, horizontal landing, our vehicles would be less susceptible to weather-related launch delays, and also diverse missions in a single launch. Thank you.
Okay, so can we just give this group a round of applause because it's a tough judging panel. It's really tough to get on any stage. It's tough to be an entrepreneur, to be passionate about your technology, move it forward, and share that vision. And much tougher, I think, to sit in front of people of this caliber. So, and at a Space Symposium. Oh my goodness. Talk about the technical of the technical audience. So, you know, kudos to you guys. You guys did a great job. They really practiced really hard today, and they probably don't like our team very much, but we're trying to help you. That's really it. Right now, we're gonna pass it off, and so I'd like to ask you, what do you think about that for your first time?
I thought it was incredible. I understood only about 10% of it. So
That's okay.
I'm a poli-sci guy. There are dozens of us in the industry.
That's okay. We won't hold it against you. Please. So we're going to pass this off for the judges. If you guys can reset the clock for 15 minutes and let you guys ask questions. As soon as they're done, their 15 minutes are up, then we are going to head off to the room over there. There's only one open door for just the judges. We'll head over there. We'll make the top selection. We'll announce the winner. So it's off to you guys. Thank you. Just share the mic.
Okay.
I'll start. So, question for Steelhead. There you are. Has your technology been employed terrestrially? You talked about space applications, but do you have terrestrial applications already deployed?
For the piston accumulator.
Okay.
Yes.
I've got a question for Oxford. Is the deployable antenna architecture scalable beyond 5 meters?
Yes, yeah, we've got a different type of architecture where we can get up to around about 25 meters. Yeah.
Have you tested the membrane in space? I mean, how its lifetime is?
We've subjected it to environmental testing terrestrially. Its first flight is, in fact, in Q1 next year. But so far, the results are looking really good. A lot of exposure to things like atomic oxygen, for instance, getting really, really good results.
I've got a question for Amanda from New Promethean. So I'm not a double E or anything like that, but
Neither am I.
Can you talk about how much radiation protection that graphene material provides? What can you equivalence it to something? Layer of water, whatever.
I'm not sure I can answer that, but Talis might be able to.
Thank you very much for the question. We appreciate your interest. We have not tested this in space, and we have not been able to get an opportunity to. So if you'd like to go over this in more detail in the future with some of our physicists and electrical engineers, I'd be happy to set up a call. But in respect for everyone else's time, I'd like to postpone that answer.
But if I can follow up on the same kind of question. I am a double E. But have you actually developed anything electrically, and what application have you considered that a powered, what kind of system?
Do you want to take this?
Go ahead.
So the great thing about the nano antennas, the rectennas, is that it can generate electricity from any type of radiation, depending on the type of nano antenna that we tune it to. Basically, we tune the nano antenna to pick up the certain wavelength depending on what we're aiming for. So there's a wide spectrum radiation that we can pick up and convert into electricity, whether it's terrestrially or in space.
Okay, and you also talked about power systems being integrated into that, in addition to antenna technology.
Power systems.
No.
So I'm not an EE, unfortunately, but I would be happy to connect you with our EE PhDs and physicists, but I'm an MBA, so.
So question for Matthew Sanders for the,
Hi.
How does this compare to other autonomous type of robotic surgery activities that are on the market or soon to be emerging on the market?
So I can't necessarily speak to all the technologies out there, but what we feel is novel about this system is it uses something called the T-bone, where real experienced expert surgeons will perform surgical simulations, and we will track their movements and update a neural network algorithm to, sorry about that. So we take live surgical experiences and their intrinsic knowledge about how to perform it, and we're able to analyze that and then use that to perform the procedure. It's not necessarily based on any set algorithm. It's constantly updating based on experience.
So it's fully autonomous?
So within a procedure, the robotic surgery system is fully autonomous, and it is performing all the instrument movements based on what it sees. However, we do feel like there should be a human oversight in something like this, and human checkpoints. So in that way, it's a little bit semi-autonomous because you want to be able to, once it completes a procedure, have the human say, yes, we're good to move on, or maybe adapt.
But humans aren't the same on the inside. So how does it make decisions when it encounters something completely different it's never seen before?
That's right. So the goal is to use the surgical training data sets to update the algorithms so that it can make decisions as it sees new dimensions or new geometries or how people are different on the inside. And that's related to the temporal bone data that we can get back out. And I'd love to talk to you more about.
Okay, I get the model building and the algorithms, but what hardware platform, or is it targeted to a specific hardware platform?
It's not targeted towards any hardware platform. It can be used on any surgical robotic system. So we saw a passion for long-range missions in space, so we see it applicable for surgical systems, but taking it a step further, it can apply to other robotic systems performing other tasks.
What are the energy requirements for your system?
So we're not on the hardware side. It's just on the software side. So, you know.
I'm talking about, so what on the hardware side would be needed, because you had talked about utilization in rural environments, and I was just curious about that.
Yeah, that's a great question, and that's really dependent on the surgical hardware system, which we're agnostic to, so it would depend on which one's being used. It could be different. We're just a control algorithm controlling it. Thank you.
And you said that that it was learning based on simulated surgeries that you guys are doing. So how many simulated surgeries have you guys done so far?
So there's just been one, the mastodectomy, that we've been performed using the system.
I have a question for Physio. Your smart garment, I saw glucose was one of the things that you guys read. Can you talk about that?
I can definitely talk to you offline about that, because how we're doing is really proprietary. Okay. But I'll definitely be happy to. It's a lot more technology that I didn't go over.
Webcast it. Is your IP in order for that?
Correct.
Okay.
I have another question for you. You said that it was not bulky, didn't have a lot of wires and stuff. What sort of form factor and how does that fit in so that it is comfortable?
All right. That's another one I like to talk offline with. Because the technology that we're using is it's kind of rare that it's being used in different applications right now. So just want to keep that under the wraps, if you guys don't mind. That's the secret source.
I'm going to keep the pressure on you here. So is your garment compatible, let's say, with astronaut cooling suit garment?
I mean, that's the intent. Right now, we haven't really had the opportunity to test it, but we can say that it is compatible with third-party applications and systems.
Is it wireless?
Yes, it is wireless.
So a heads up for all of you in the audience and us judges. Our inventors here have been advised this is being live streamed globally, so they've been told to be cautious about what they say.
Got a following question for Clepsydra. Yes. You talked about the wind turbine application, the inspection of wind turbines.
Yes.
And you also mentioned some space applications.
Yes.
Can you give us some examples of what you think these space applications might be?
Well, any high data rate processing can benefit from increased throughput at lower CPU utilization. So the sensors for a lunar lander, a robotic satellite servicing mission, autonomous rendezvous and docking, any of those kind of things have huge amounts of sensor input in order to be able to accomplish their job. And if you can embed our software package and get a 40% greater increase in your processing without having to add any more CPUs or any more power, it just helps high data rate applications work better. So turbocharging, in effect.
I've got a question for Tim. There's a lot of people that are passing metadata in your wheelhouse. How do you see the competitive environment for you? What separates you from your competitors?
So we do not collect the data ourselves. We're analyzing the data that's already been collected. The metadata behind it is just another layer of data that we can put into, with the algorithms that we're running across it. It can actually be part of the analysis. So you can actually look at the top layer data and the metadata and how it actually behaves with the data and see if, in fact, that data is altering the behavior of the top layer. So metadata in the other sense, with all the different pieces of information that we're getting in imagery and indoor streaming data, each of them have a behavior to them in that when you start interweaving them with each other, they start becoming, we'll call them behavioral signatures. Once we have those signatures that we can identify with the subject matter experts at hand, then we can pass that into a machine learning environment and hopefully have the machine learning environment make it a little less taxing for the analysts that are looking at that data at those minute levels.
Question for New Promethean. Often materials that are used to protect against radiation are degraded by that radiation. Have you tested that, if it's going to continue to have the ability to harvest?
So we haven't tested that. Great question, by the way. Thank you for that. We have not tested it ourselves, but there is a lot of literature out there. And the way we're collecting the radiation, turning it into electricity, if you could picture a catcher's glove catching a baseball, it's very similar where we have the rectenna tuned to a particular frequency of the radiation. So we don't believe that there will be any degradation.
Question for ion power. Are your carbon fibers consumables, and if so, how long do they last?
We've had continuous testing underway for over 5 years at our test site in Florida. And actually, the wear and tear on the fibers increases their area and slightly improves as time moves forward because they spread out and harvest more ions.
Question for Atlas Power. What's the largest storage device you've built to date in watt hours, and how long did it take to charge from a complete discharge?
So right now we're moving to demonstration phase. So we have 2 university collaborations back in Canada. One of them's with Simon Fraser University, the other's with UBC. So UBC, we've got a great team there, and we have a proprietary ultracapacitor recipe that we've been working on. So it's at lab scale, so button battery sizes. So there's really 2 parts to our technology. One is the actual storage medium, and the other is the actual charging technology, the deflection conversion technology.
Can you give some measure of power density?
I can. I've got all the figures sitting over there, but it's comparable with existing ultracapacitor technologies in the marketplace. So if you're looking at power density, that's usually a factor of 10 or 20 over batteries.
So Miguel, AstroClipper.
Yes.
How advanced is your concept? What TRL and what IP do you own on this novel concept?
We have 3 patents, 1 patent for the inline staging and 2 patents, 1 for space applications and another one for aero applications. And we are at TRL, we'll say 2.5, very close to 3.
Thank you.
A question for Physio. How does the accuracy of your vital signs measured at conventional devices, and how does it deal with motion artifact?
All right, right now, through 50 case studies, our accuracy sits anywhere from 93% to about 97%. And the fact that we have more data points than conventional ones kind of boosts our accuracy and keep it pretty consistent across the board. What was the second part of the question?
Vibration artifact or motion artifact. If your astronauts are going to be working
Mm-hmm.
and moving and doing things and during launch, if you're going to monitor during launch, the vehicle's going to vibrate. How does it deal with the artifact?
We're still working on that with the machine learning aspect. I mean, because that would take us, right now we're working on a use case. We're weeding out the feedback over like 30 consistent trials of doing over a 30-day period. That way the government can learn what the users are doing or just learn the situation.
And what's the lifespan of this garment?
The lifespan, once we launch it, we're looking anywhere from 6 months to 12 months of a use case. Wow.
So let me just say, even the judges get the shark sound because we are on a tight schedule. So can you guys give everybody a round of applause, the judges and the entrepreneurs? I just get to participate in all of this. So if our judges could actually head back to that open room back there, we've got a speaker that's going to be joining us. Slide, please. And the entrepreneurs, if you guys can exit, you want to have a seat, grab a drink, breathe a little, let your hair down. I don't know if you might not have any.
And some tough questions.
They are. And so we have a guest speaker, and I hear you guys work with McKinsey some, right?
Yes, Space Foundation.
I don't know.
Space Foundation is a big fan of McKinsey. We love working with them. And so...
Who is it that's coming?
Jesse Klempner is a partner at McKinsey & Company. So without further ado, let's welcome Jesse to the stage.
Thank you. So, thank you for inviting me, Kira. Really, really appreciate it. I think we can probably move to the next slide. We live in an incredibly exciting time in the industry. It is one where you can put a deposit down on a commercial space flight. You can get live video of Earth any time of day. And you can think about supersonic travel once again in the not too distant future. The Aerospace Industry Association began to think about this question of what is the future going to look like? And they said, well, let's pick a date that's far enough out that it is not beyond the realm of the possible, but it is one that is exciting and aspirational for all of us. We had the privilege of partnering with AIA to think about what the world's going to look like. To do that, we had the opportunity to talk to a lot of people, but at its core, the headline from the study was, the industry is going to be even more central to our lives in how we work and how we do business, how we communicate, and how we live in 2050 than it is today. Go to the next slide, please. As I said, we had the opportunity to speak with more than 70 industry leaders, government leaders, leaders of our armed forces, investors, and new entrants into the space. We got the opportunity to ask them a wide variety of questions, two of which I think are most relevant to our conversation today. What are the future missions, use cases, and platforms that will emerge across domains? And what are the key disruptive trends that are impacting the industry? What you see on the bottom are a subset of the folks that we got the opportunity to speak with. And all of them, to their credit, and which we're deeply appreciative for, were incredibly generous with their time and were incredibly candid about their views on where the industry was heading. Next slide, please. At the same time that we begin to think about the future, in the background there is a confluence of trends that is uncontrollable by many of us and is going to affect where the future is headed. I'm going to touch on a few of them. There's a number of them listed here. But the competition for talent and the growing skill gap is very real. And it is going to continue to be real to such a degree that by 2050, we may have a requirement that we have to relax some of the constraints in which we have lived. We're going to have to revisit some of the accepted truths that we have abided by. And we may have to change who and how we hire and incentivize people within the industry and outside of the industry. At the same time that we are doing that, there is a widely variant set of capital sources that are changing how we are incentivized and how we think about interacting with our customers, with our investors, and with our supply chain. And finally, one that would not necessarily seem particularly exciting for this conversation, but will be incredibly important to all of the new entrants and startups that had the opportunity to present today. IP ownership and liability is going to need to shift considerably in the industry if we are going to enable and provide returns on all of the investments that people are putting into this industry. Next slide. We tend not to think of the industry in terms of the traditional domains, air, sea, land, nor do we think of it in terms of commercial and government. We don't necessarily think those are the right ways to segment this industry. We think about what are the missions that the industry more broadly solves for society. The industry moves people and goods, both for government customers as well as for tourism and for business travel, or to deliver many of the goods that all of us rely on every day. At the same time, it senses and connects many of us, whether those are communications that flow through space or pictures that come down from space that enable us to predict the storm that is coming our way, our travel, or to count cars in parking lots. It secures and defends our national interests. It drives research and exploration for its own sake, and it provides a set of essential services that underpin the industry and all of the things that we do today, such as air traffic management or positioning, navigation, and timing, which most of us think of as GPS. Slide. One of the reasons that we and the more than 70 leaders that we spoke to were excited about this is that there are a huge number of new growth opportunities and frontiers that are arising and will arise by 2050. And just to ground all of us, 2050 may sound very far away. It is no further away than 1990 is in the past. By 2050, we believe that unmanned aerial vehicles, whether they be for people or for cargo, will be widespread and will change the way that we move and the way that commerce works for all of us. For the folks here at the Space Symposium, we believe that space tourism and transport is not hype. This is something that will be nascent by 2050 and will begin to be something that we consider more frequently as an alternative for how we spend our leisure dollars. Similarly, space manufacturing and mining, which was something that we may not have thought much about that long ago, is not that far off in the future. Again, 30 years is not that far. Similarly, on driving research and exploration, commercialized exploration is something that will be, again, emerging by 2050. This is a huge set of emerging opportunities and use cases and growth opportunities for all of the new entrants that presented today, some of the more established industry participants, as well as folks that are adjacent to the industry and are considering whether this is an exciting place to be, which unequivocally we think it is. Slide. What we describe as Vision 2050 won't happen on its own. These are things that need to be fostered and enabled by government, by society more broadly, by the talent that would flow into the industry between now and then. And so we began to think a bit about how should we enable and accelerate these opportunities for the future. Next slide. We thought, along with the 70-plus participants and our AIA partners, about a set of 6 enablers that we think are critical between now and 2050. To touch on just a few of them, the first enabler would be something around autonomy and insights. Without advancements in autonomy, we will not be able to have unmanned traffic management, autonomous decision-making, or some of the significant insights from unstructured data that we're all counting on in the future. Similarly, just to jump a few rows below, many of us see the images of flying drones or taxis, and if any of you have been to the AIA interactive wall, which is in one of the pavilions, you will get a visualization on your phone of how this might work. Many of us don't think about the more mundane tons and tons of concrete that we may need to pour for physical infrastructure, for delivery, for docking, and for landing pads. This is significant, but you cannot get to our vision of an established, unmanned version of the future without it. At the bottom, we also talk about there's a mindset and culture component that is pervasive and consistent. And this is not just a perspective on the industry participants that have been around for a very long time. This is a mindset and a cultural shift that is across the ecosystem. All of the stakeholders need to begin to think about transitioning from career paths to opportunity pathways, which is how the rest of the commercial industry thinks about that they have and that they're hoping to attract. Next slide. We believe that to drive Vision 2050, the industry and participants and stakeholders should consider a number of priorities. We've listed 5 of them here. At its core, we believe these are the ones that people should focus on because the industry is headed towards an inflection point on so many levels. There are going to be shifts in the profit pools in the value chain. There are going to be new use cases, and there are going to be existing use cases that decrease in importance. We believe that remaining competitive or increasing competitiveness with some of the other folks that may be focused on this, be they from our country or others, will require evolving, acquiring, a new set of capabilities, as well as being able to work with a new type and set of industry participants. When we think about what those actual priorities are, and the AIA was forward-leaning on all 5 of these, we think about partnership and collaboration with a new type of industry participants needs to change and evolve. Established corporate policies on who we can partner with and why, be they because of IT regulations or because of their perspectives on ITAR, need to continue to evolve so that emerging use cases can be enabled by the new technologies that may be held by other industry participants. We also believe that investing in new use cases can't just be done by the 10 companies and others like them that are focused on this. This needs to happen across the industry. It needs to happen with customers. It needs to happen with the larger and more established players in the industry, as well as some of the growing new entrants that have staked out positions on many of these new use cases. There also needs to be a concerted effort on defining standards. Standards both for technology and standards for interaction. This is a place where the United States has led the world, and the world has looked to us for leadership for many, many years. Concerted efforts here need to occur so that this is not ceded to others who may not think about safety in the same way that we do. Similarly, we also believe that there need to be significant internal capabilities, both on the established players and the new industry participants that need to change. Whether those are technologies that come from adjacent industries, like the technology industry, or some of our more established industrial companies, these are things that the industry needs to be more proactive in capturing so that we can begin to accelerate the acceptance and the use case prototyping. Finally, and not to under focus on this one, we believe that transforming industry-wide culture and processes is crucial. There needs to be a consistent and sustained focus on recruiting and retaining talent, fostering innovation, and incentivizing innovation. We believe that this is the core of what has made the industry such a powerhouse for the country and for the world for many, many years. And there's much, much more to be done here to enable what we believe is an incredibly exciting vision for how central the industry can be for our future. So thank you all for listening. I hope you look forward to listening and learning about who the winner is, and look forward to hearing from many of you. Thank you.
Thank you. Well, so surprisingly, we actually have selected a winner for tonight. And any bets want to go on against which one will be the winner? No, I'm just kidding. I'm not really a betting girl.
I think casino night was last night, actually.
Oh, I missed it. So if you guys can actually come in, I know this is going to like require your attention, but I'll wait until you guys want to move in and give the winner and the entrepreneurs a chance to actually, yes, I would like all of our entrepreneurs up on stage. If you have wine, I'll drink it. No, I'm just kidding.
Part of the new gin part. Thank you for doing that. Great. Awesome. Thank you very much.
And so, so there was a slide up there a second ago that disappeared that you were going to talk to. We want to thank.
Right. So we want to thank our sponsor, Lockheed Martin. Lockheed Martin is such an impressive company, and Space Foundation could not do what we do, and educate the K-12 students that we educate without support from sponsors like Lockheed Martin. So thank you very much, Lockheed.
Wait, I got to say something about Lockheed. So they've been really supportive, and they always send someone to our Ignite the Nights or our forum. And I've always said if I was a contractor for a space agency who was identifying gaps in technology and bringing in entrepreneurs and backing off and getting out of their way, that I would always show up as well. And so they've been really, really supportive of what we've done, and we couldn't have done this without them as well. So thank you, Lockheed. I know you guys are out there somewhere. So hopefully I'll find you before I leave. The next thing I want to say is that you guys did an amazing job. You show up 8 in the morning, we gruel you, we tell you, no, you can't say this, yes, you can say that, change this, what the heck, nobody cares about that. You know, we tell you things like that. And yet, you still persevere. So we're just training you for being real entrepreneurs, right? Because you're going to get people telling you no, not to say this or do this all the time. What I want to point out, though, is the technologies that you're developing, you're passionate about it because you believe it's going to solve a problem. Don't give up on that. This here does not, whether you're the top winner tonight or not, that top winner just advances as a semifinalist. But it doesn't mean that your technology's not valid. It just means that we could only pick one. Your applications are still in consideration for the big forum that we will have, every one of you, that we will have in Pasadena on the 11th and 12th. And so this is the worst part. Wait, Peter's supposed to be here. Can someone grab Peter out of that room? Oh, Peter's here. Oh, good. The people who did the hard work. So Peter's going to give a couple of. He's going to talk a little bit about some of the technologies. Get up here.
Well, I was just going to talk about the winning technology.
They can't hear you. Okay, just talk about the winning one. Here. So let me. So the top winner is Oxford Space Systems. I think he's surprised. And so Peter wanted to give a few words about that. And Jeff DeWitt, are you in the audience? Jeff is NASA's chief financial officer for the agency. And this is his first time to one of the Ignite the Night events. And so I'd love to get what your thoughts were on this as well. That's okay. Here, scoot in this way.
I know, buddy.
No pressure. He didn't know.
Well, first I'll say, if you could see how hard Kira works to put this on, and even at headquarters every day, in what she's doing, not only for entrepreneurship at NASA, but across the country, and to get these technologies and to put all this together. So if I could ask all of you for a nice round of applause for Kira Blackwell and all the work she does.
That's yours.
And what I can say is I'm very proud of all these companies up here. Everything you're doing is hopefully helping us get to the moon faster, cheaper, and bringing forth the better technologies. And we're trying to drive an entrepreneurial spirit back into NASA to move faster and do these things. And a lot of that starts with the hard work that Kira's doing. So thank you all for coming and supporting this. And it's a wonderful program that we're just so proud to have at NASA. So thank you, Kira.
If you hand that to Peter, he's going to talk a little bit about why, the top winner tonight. And then one thing I'm going to say is the other entrepreneurs, don't hesitate to grab some of the judges that are there, because they would love to engage with you to talk about your technology and maybe help prepare you for the forum. Right? So I know you're hungry and you want to drink, but find them. Look at their faces, find them, because they're here volunteering their time to help you as well. So go ahead, Peter.
Thanks, Kira. So as you witnessed, we have the tough decision of selecting down from the 10 to the top 1 that we're going to award here. The judges, we deliberated for about the last 15 minutes, and we ranked them and rated them and talked about some of the merits. Oxford Space Systems really came forward with a really novel deployment mechanism for composites that has very widespread application both in space and terrestrially. The description here today was very clear about the technology, what made it unique, and really discerned it from other type of offerings. We also really liked how it had clear performance data, what separated this from other type of solution spaces, and made it clear what that commercial and space applications were. He had an advantage that he had some toys to show, and that's unfair for those of us in the software arena, but it is good.
Toys are always great.
But when you're
especially
selling
in
something,
this environment.
You really have to be able to convey what your message is.
Yes.
So big round of applause for Oxford Space.
And I just want to say thank you, everyone, for participating. A shout out to our live streamers. Thank you for joining us tonight, because you guys are amazing. And we look forward to some of you guys being able to participate in our forum in Pasadena, California in July, on July 11th and 12th. So I think we have a little video really quickly. Well, thank you, everyone. Have a great night. We're going to do a couple pictures up here. If you guys want some too, stay up. And then go get drinks and have some food. Enjoy the evening.
Congratulations. Congratulations.